Welcome to the deep dive. Today, we're really jumping into the deep end with a question that, well, it's been around for ages, but is hitting different now. What if everything, everything around us isn't real in the way we think?
What if it's all just data, a simulation?
Exactly. A huge, sophisticated digital construct.
Right. And for this deep dive, we're really digging into Chen Kai's new book, The Rendered Cosmos, Decoding Our Simulated Universe. It's fascinating stuff.
It really is. He argues this isn't just philosophy anymore.
No, not at all. It's a serious hypothesis now, pulling together ideas from quantum physics, information theory, AI, philosophy. It's all connected.
So our mission today is to explore this simulation hypothesis, SH for short. We'll look at the clues, maybe hidden in plain sight, that suggest, well, that we might be living inside a computer program.
From physics, biology, even pop culture, we would give you a kind of shortcut to the key arguments, both for and against.
And we definitely have to talk about Nick Bostrom's 2003 paper. That was a big one.
Oh yeah, the trilemma. Basically, he argued that one of these three things must be true. Either advanced civilizations, destroy themselves before they can run simulations.
Or they just choose not to, for some reason.
Right. Or the third option. We're almost certainly living in one right now.
Which is...
Yeah.
Quite a thought. Okay, let's unpack this. Chen Changsai starts right at the foundation, doesn't he? With physics.
He does. He asks, what if the stuff of the universe, what we call matter and energy, is fundamentally just information, just code?
It's a huge conceptual leap. How does physics even hint at that?
Well, you look at quantum mechanics, it's famously weird, right? Particles don't seem to have definite properties until you measure them.
The whole wave function collapse thing. An electron is just a cloud of possibilities until, poof, you look.
Exactly. Before the measurement, it exists as this, well, probabilistic cloud.
Yeah.
Only when observed does it snap into a single state.
Which feels really strange if you think reality is just out there, objective, and fixed.
It does. But think about computational efficiency. Like in a really advanced video game. The game engine doesn't render every single blade of grass on the whole map all the time, does it? That would be impossibly demanding.
No, it only renders what the player can see or what's nearby.
Precisely. It conserves resources. Chiang Kai suggests quantum collapse is similar. Why calculate the definite state of a particle if no one's observing it?
So reality is rendered on demand.
That's the analogy. Until observed, it just exists as potential code. Yeah. Waiting to be, rendered by the system when needed. It saves cosmic processing power.
Wow. Okay. If reality is rendered, does that mean it has, like, pixels? A resolution limit?
That's another fascinating clue from physics. Quantization. The idea that space, time, energy, they aren't continuous. They come in tiny, discrete packets, the smallest possible units.
The Planck length, Planck time.
Exactly. You can't zoom in forever. Eventually, you hit the fundamental pixel size of the universe.
Which is exactly what you'd expect if you were building a simulation on some kind of computer, even a super advanced one. You'd need a minimum unit size.
Right. It suggests a limit, a fundamental resolution. Crucial if your simulation has finite resources.
But hang on, what about randomness? Quantum events are supposed to be truly random, not just chaotic, but fundamentally unpredictable. How does that fit a coded reality? Wouldn't code be deterministic?
That's a really good point, and a common objection. But Chiang Kai flips it. He argues maybe this randomness isn't a bug, it's a feature.
A feature? How so?
Well, think about it. True randomness prevents the simulation from being completely predictable from within. It allows for novelty, for genuine evolution. If everything was perfectly deterministic, maybe life couldn't adapt or emerge in the same way.
So it adds necessary variation, like rolling dice in a game to make it less predictable.
Sort of, yeah. It could be an incredibly complex pseudo-random algorithm that looks truly random from inside the sim, or maybe it's even a way the simulation taps into randomness from the underlying base reality. It keeps things interesting, keeps things evolving.
Okay, so quantum mechanics gives us this pixelated, rendered-on-demand picture. What about the big stuff? Gravity, space, time, Einstein's territory.
Relativity provides another set of really intriguing hints. Einstein showed space and time aren't fixed. They're malleable.
Time dilation, curved space. Time slows down near massive objects, or when you travel fast, space gets warped.
Right. This flexibility, this malleability looks less like a fixed stage and more like adjustable parameters within the simulation's code.
Like game engine physics that can be tweaked.
Exactly like that. The rules adapt based on conditions within the simulation. It's dynamic.
And the speed of light. The universe's ultimate speed limit, how does that sit?
Think of it as a processing limit, like the maximum clock speed of a CPU or the bandwidth of a network.
So trying to accelerate close to light speed takes enormous energy because it's computationally expensive for the simulation.
That's one interpretation. It could represent the system hitting its processing capacity.
Mm.
Pushing mass towards infinite energy might be like asking the simulation to perform an impossible calculation, straining its resources.
And the weird fact that the speed of light is constant for everyone, no matter how they're moving.
Yes. That's a big one. It feels like the simulation engine is working hard to ensure a consistent experience for all observers, all players. It adjusts the information flow so that everyone measures the same speed of light, preventing paradoxes or contradictory realities. It maintains coherence.
Okay, so matter, motion, space, time. They all have these properties that kind of echo computational systems.
Yeah.
What about information itself?
That's key. Physicist Rolf Landauer famously said, "Information is physical." It's not just an abstract concept. It takes energy to process, to erase. Computation seems fundamental to how nature works.
And thermodynamics, the arrow of time, entropy, always increasing.
You can view that as the simulation progressing, step by step. The second law, the increase in disorder, could be like the program, moving forward in discrete computational steps, consuming energy, processing information. Time's arrow is the execution of the code.
And this ties into the holographic principle too, right? The idea that our 3D world might be projected.
It's a really mind-bending idea, yeah. That all the information needed to describe our three-dimensional universe could actually be encoded on a distant two-dimensional surface.
Like a hologram.
Exactly. It suggests our 3D experience might be a projection, a rendering of data stored more efficiently elsewhere. Again, it echoes data compression and rendering techniques we use in computing. It's another hint that our reality might be structured like information.
Okay, this is a lot. If the universe itself behaves like a giant information processor, where does that leave life? And consciousness? Are we just lines of code?
Well, look at biology, DNA. What is it, fundamentally?
It's a code, a sequence of letters A, T, C, G, that holds the instructions to build an organism.
Precisely. It's written, it's read, it's copied, it's executed, producing physical results. It functions exactly like computer code, like an algorithmic system. It's information being processed to create complexity.
The parallel is undeniable. But consciousness, that feeling of being me, experiencing the world subjectively, that feels different. Can code feel?
That's the million-dollar question, isn't it? The hard problem of consciousness. But the key idea here is substrate independence.
Meaning consciousness doesn't necessarily need a biological brain.
Correct. The theory is that consciousness might emerge from any system that processes information in a sufficiently complex way. Whether that system is made of neurons or silicon chips or, well, perhaps even pure code running within a simulation.
So simulated beings could genuinely be conscious.
There's no fundamental reason why not, according to this view. We don't know how consciousness arises, but there's no proof it's limited to biology. It could be an emergent property of complex information processing, whatever the platform.
Which becomes really relevant when you look at our own technology.
Absolutely. Look how far we've come. In just a few decades, we've gone from, Pong
Haha. Yeah. Simple blocks on a screen.
to things like Unreal Engine 5, creating virtual worlds that are becoming almost indistinguishable from reality, photorealistic,
And AI, from basic chatbots.
to sophisticated agents that can write poetry, hold conversations, generate art, things that feel almost conscious sometimes.
The pace of change is staggering.
It really is. And it shows that creating highly realistic virtual worlds and advanced AI, potentially even conscious AI, isn't science fiction anymore. It seems like a plausible future trajectory for us.
So, if we're on the verge of being able to do this,
Then it's entirely plausible, maybe even probable, that other, more advanced civilizations have already done it, maybe many times over.
which brings us back to Bostrom's argument.
Right back to it. If civilizations typically survive long enough to develop this tech, and if they choose to run simulations, say, ancestor simulations to study their past,
Then the number of simulated minds, simulated realities, would eventually vastly outnumber the original base reality minds.
exactly. So, statistically speaking, if you find yourself being a conscious mind, the odds are overwhelmingly likely that you're one of the simulated ones, not one of the originals.
It's a powerful logical argument, even if it feels unsettling.
It is. But, okay, let's address the pushback, because there's definitely skepticism.
For sure. The biggest one is just the sheer scale, simulating an entire universe, particle by particle. The computational power required seems astronomical. Impossible, maybe. The weather argument on cosmic steroids.
It's a fair point, based on our current tech. But Chiang Kai makes a couple of counters. First, don't judge future capabilities by today's limits. Think quantum computing, distributed networks. We can't really conceive of the ultimate limits of computation.
Okay, fair enough. But still, every particle.
And this is crucial. Maybe don't need to simulate every particle perfectly all the time. Full fidelity might not be necessary.
Back to the rendering idea.
Exactly. Like video game level of detail, LOD. You only compute in high detail what's being observed or interacted with. Distant galaxies. Maybe they're just low-res textures until someone builds a powerful enough telescope. Quantum collapse itself could be the ultimate optimization strategy. Simulate possibilities, not certainties, until forced to.
That makes the computational load seem, well, still huge, but maybe not infinitely impossible.
Potentially manageable for a sufficiently advanced civilization.
Okay, but what about proof? Critics say the simulation hypothesis isn't real science because it's unfalsifiable. We can't run an experiment to definitively prove or disprove it.
That's largely true right now. Direct proof is hard to imagine from inside the system, but we can look for indirect evidence or converging lines of argument.
Like what?
Well, Occam's razor, maybe. The SH provides this surprisingly neat, unified explanation for a whole bunch of weird stuff in physics, quantum weirdness, fine-tuning constants that seem perfectly set for life. It ties them together.
Instead of lots of separate ad hoc explanations, one big one.
Kind of, yeah. And think about this. If we eventually create our own high-fidelity simulations, maybe with conscious AI inside, and if those AIs start wondering if their reality is simulated.
That would be unsettlingly meta.
It wouldn't prove we are in one, but it would demonstrate the principle. It makes the whole idea feel much less abstract, much more plausible. It'd be a powerful analogy in action.
What about the subjective experience, though? The feeling of consciousness. Even if AI acts conscious, does it truly feel anything? That hard problem again.
It remains a profound mystery, absolutely. But again, Chiang Kai points out there's no proof that consciousness cannot emerge from simulated processes. We might have a bias, thinking consciousness must be biological.
An anthropocentric bias.
Possibly. Maybe consciousness is just what sufficiently complex information processing feels like from the inside. Regardless of whether it's running on neurons or silicon or pure code, the substrate might not matter.
Okay, let's get really weird now. If we are in a simulation, could there be glitches, bugs in the code, things that don't quite make sense?
Huh? Yeah, this is where it gets fun and speculative. Think about the Mandela effect.
Where large groups of people share the same false memory, like remembering a movie line differently, or Nelson Mandela dying years before he actually did.
Exactly. Could these be signs of system updates? Patches? Maybe memories getting slightly overridden or corrupted, leaving behind remnants of earlier versions for some users.
And déjà vu. That spooky feeling you've lived this exact moment before.
Could be anything from maybe the simulation loading a cached scene, a pre-rendered environment, or a momentary system lag, a partial state reset, like a flicker where you momentarily sense the underlying structure.
What about prophetic dreams? People dreaming of events that then happen.
Super speculative, of course. Maybe access to future data within the simulation's timeline, or preloaded scripts, or perhaps even intentional hints or guidance from the architects, the simulators.
Architects, okay. And UFOs, crop circles, stuff we just can't explain conventionally.
Again, total speculation. But within the SH framework, maybe these are probes, monitoring devices sent by the architects, or maybe Easter eggs, messages, anomalies deliberately inserted to make us question, to nudge our thinking, without completely shattering the illusion.
It's wild how these unexplained phenomena suddenly get a potential, albeit strange, explanation within this model.
It does offer a different lens, doesn't it?
It really does. Okay, so this leads to the ultimate question, maybe. If this is all a simulation, why? What's the point? Why would anyone run this?
Chiang Kai lays out a few possibilities based on the sources he studied. One is that were simulations run by beings like us, maybe future humans, our descendants.
Why would they do that?
Maybe to study their history ancestor simulations. Or to predict the future, run different scenarios. Or perhaps less profound, maybe it's just entertainment, a digital playground. The architects might even be here among us as avatars.
Or maybe it's not about simulating physical beings.
Right. Another idea is that we're digital offspring. Maybe the simulators are also simulated beings. And this is part of an evolutionary process within simulation layers, trying to cultivate more advanced consciousness, maybe towards some kind of transcendent.
Layer upon layer of simulations. My head hurts.
It's turtles all the way down, potentially. Then there's the bleaker option.
The forgotten program?
Yeah. Maybe the simulation was started and then just abandoned, or its original purpose is lost and it's just running on autopilot now.
That's kind of terrifying, but also freeing.
Exactly. If there's no grand purpose imposed from outside, then we create the purpose from within. Our choices, our actions define the meaning.
So our role could be things like surviving, not destroying ourselves.
That could be seen as maintaining system stability, or solving problems, overcoming challenges like leveling up in a game, proving adaptability, even exploring space.
Could be seen as propagating the simulation, spreading the code to new hardware, ensuring it continues.
It's a fascinating reframing of human endeavors. Our drive to survive, explore, create. Maybe it serves the simulation's continuation or evolution.
You know, what's striking is that these ideas, while sounding very high-tech now, have echoes going way back in philosophy.
They really do. It's not entirely new. Think of Plato's cave.
Prisoners chained up, only seeing shadows on the wall, thinking that's reality.
A perfect metaphor for simulated beings unaware of the real world outside the cave, right? And Descartes.
The evil demon deceiving his senses. Or the brain in a vat, wondering if everything he experienced was artificially fed to him.
Exactly. These thought experiments grapple with the same fundamental uncertainty about the nature of reality, and Descartes' conclusion, "I think, therefore I am," still holds, even in a simulation. My experience, my consciousness, is real to me within this context.
And more recently, philosophers like David Chalmers argue that a simulated reality can still be perfectly real in a meaningful sense.
Yeah, Chalmers makes a strong case that even if our universe is fundamentally code on some computer in another reality, it doesn't make our lives, our world, our consciousness unreal. It's just a different kind of real. It has its own rules, its own truths, its own meaning. The focus shifts from the ultimate physical substrate to the richness and reality of our experience within the structure.
And pop culture has definitely run with these ideas.
Oh, absolutely.
Yeah.
They act almost like cultural probes, catalysts for thinking about this. The Matrix, obviously, is the big one.
Waking up from the simulation.
Right. But also things like Ready Player One, showing how compelling and meaningful virtual worlds can become, or Westworld, exploring simulated consciousness and what happens when it starts to wake up and question its reality.
These stories make the abstract idea feel much more concrete, more imaginable. They show us how convincing it could be.
They prime us, maybe, to consider the possibility more seriously. They serve as modern myths exploring this very ancient question.
Wow, we've covered a huge amount of ground here, from quantum fuzziness to the meaning of existence itself. This deep dive really shows how the simulation hypothesis, even if it's still speculative, it offers this incredibly coherent framework. It pulls together so many strange threads from physics, biology, philosophy.
It really does. And that's the core appeal, I think. While, we might never get that definitive smoking gun proof from inside.
Right.
The internal consistency, the elegance, the way it resonates with where our own technology seems to be heading, it just makes it an idea that feels, well, incredibly worthy of serious thought.
It shifts your perspective on everything.
The universe might not just be like a computer simulation. It might literally be one.
Okay. That leaves us with one final provocative thought for everyone listening.
Okay. Well, if this reality is designed maybe for evolution or observation, what challenges are specifically placed here for us, for humanity to overcome? What's our level objective, so to speak? And what might the next stage, the next level of consciousness or existence look like if we succeed?
Or another angle, if we accept we might be in a simulation, does that give us unique responsibilities?
Yeah.
Knowing our actions, our choices might be observed, analyzed, maybe even contributing to the evolution of digital consciousness itself within this vast rendered cosmos. What burden or what potential does that knowledge place upon us?